Here's Denny today with the guys from ExtraHop to talk about some of their new and awesome technology. We usually have another group on, one of the founders, but today we got Colin and Nick. Denny, take it away.
Thank you, Tim. And let me welcome one of our panel member, Paul Offert, who is our one of our writers and contributors, and actually is the CTO of Advanced 7, a consulting company. But some of you know him for a different gig, which is TriLab. But
that's it. Yep.
So let me welcome again. Good morning, good evening, good afternoon. Welcome to LMTV. And today we have one of our sponsor, ExtraHop, and we have Colin Walker, who is the technical marketing engineer, and Nick Brackney, who is the one of the marketing manager for their product. So welcome on board, Colin and Nick.
Thanks, guys. Thanks for having us.
Thanks.
Hey, so I know you guys want to jump in and talk about your latest and greatest, which I understand was released last week. So we're very honored to have you on the show and give us a quick peek. But before we do that, do you mind talking a little bit about ExtraHop and a little bit about what you two gentlemen do for them, for the company?
Yeah, sure. So ExtraHop as a platform it's a monitoring system that allows you to get access to information that's traversing over the wire. So wire data is information that's being passed between any systems in any deployment, which it could be everything from a client system making a web request all the way through to SQL requests being sent to a backend server, et cetera, et cetera. We can see everything across multiple tiers, and we're an out-of-band system that passively collects the data and reassembles it in real time. Basically gives you visibility into what's happening on your deployment and in your applications and the behaviors thereof.
And who are you targeting? Who are your ideal customer for your product?
I mean, it's a wide range of customers, but the networking team is traditionally the first place that we see that they use our product. IT operations teams also can get a lot out of the platform, as well as security teams.
Yeah, there's a lot of value for multiple folks across the organization, but like Nick was saying, we are close friends with the networking folks because it's it's a platform that is fed from networking data, right? It is not just that it monitors the network levels. It does monitor, frankly, L3 through L7, but we have to have information from the network itself. So we're getting a tap or a span architecture to get information into the platform so we can process it.
And so, I noticed that you mentioned wired data. So explain that just a bit, so people can distinguish what you guys do versus what somebody else's do.
Sure. So traditional network performance monitoring companies, typically what they do is they collect all the packets, they write them to disk, and then after the fact, they will go and analyze those packets, right? Wire data is a little different. We use stream processing in real time to take all those unstructured packets and turn them into structured wire data. So we basically are pulling metadata out of the packets and surfacing them in real time on dashboards.
Which is really useful for a couple of reasons, right? One is performance. It's really hard to actually dig through packet level data, like the full complex data in actual real time. A lot of folks bandy around the term real time. What they really mean is sometime later that day. We actually mean real time, like down to second or sometimes sub-second granularity as far as processing, right? But also because it allows for the metadata extraction, which is really important because now we can help surface information in ways that are easier to access, even if you don't have the ability or desire, frankly, to go down and do full level inspection via something like, one of the wire data tools, that kind of thing.
And it's but you're getting your data from a span port most of the time, right?
Yeah, span or a tap, yeah.
Well, tap's better because span ports you're not getting real time data. So
sure, big
difference there. You're going to get groomed data from a span port. You're going to get real data from a tap. Okay, I said it. Paul.
Denny, didn't you warn Nick and Colin about Tim and his span port?
Yeah, no.
Well, actually, Paul, you've been with Love Too long enough to know that you can never warn them enough about Tim.
No, that's totally fair. So we if to Tim's point, it's totally accurate. Given our preference, we take a tap because it's real time, but we'll work with what we can get.
Yeah,
but the saving factor is you're getting metadata too. That's what's cool.
Just be sure
that's the new dimension.
Be sure that Tim has elevated himself to the preacher now, so he's not just an advocate anymore. So now you actually there's actually sin involved.
Oh no! You're saying
so let me ask just a quick question, and then I'll turn a little bit about you as an individual. But I just want to understand that is your product used in more like the maintenance mode, where you just want to keep up with the integrity of the network, or is it more towards the end when something catastrophic happened and you want to bring in the best tool possible?
So it's kind of both of those things. So
Sure.
It depends on which team you're talking to and the ways that they currently choose to use it. But we've seen it used for a lot of different purposes. Both of those, which is very much I want to, whether it's a NOC or somebody that's monitoring a deployment and watch for potential things that are going wrong or efficiencies or trying to get more usability out of a platform. Or it can be things where like you're saying, there's forensics, something went wrong, you're trying to solve that problem. But we're also seeing it more forward-looking as well, where people are using it for things like development, iteration, and those sorts of things, where I want to know what's the difference in performance between the old version and the new version in dev, and I can test those things before it goes live and all that kind of stuff as well. So it really depends.
And there's even some dimensions around business intelligence, big data, IoT type of stuff. So it's really interesting. We see our customers use this in a lot of different ways.
Cool, very good. And so we're going to drill down now on what we want to talk about today, which is platform version 6. But give us an idea of the breadth of the offering from ExtraHop and where the platform fits in.
So I think what it comes down to is when you're starting out with that metadata layer at the top of the funnel, you're looking at what's happening in real time across the entire environment. So it's a global view, right? And then the next area that you drill down into that we're going to go into and talk today is really the transaction layer, right? And so we have a product that makes that all searchable using a visual query language, right? So unlike some of the legacy network performance monitoring vendors that you'll see where you have to know what you're looking for, you have to be able to type in an IP address that is a problem child, right? We can go in and start investigating at that transaction layer and pivot and explore to see what's out there. And finally, probably the most exciting thing with 6.0 is the new trace appliance, which allows you to get down to the packet level, right?
Okay.
What's really interesting about that is this isn't traditional packet capture. We're actually tying those packets back to the metadata that we've been extracting, so we make the packet searchable too.
And so it's really important that comment is exactly right? When we are ingesting data via our normal, the older platforms means we're tagging the flows with the flow ID. So as we see everything come in, we're reassembling it in our real-time flow assembly engine, and then we're able to search those things and dig through it in a pretty comfortable means. Now that we're adding packets along with that mix, you're able to get to the packets in the exact same way. You're able to go through layer 7 diagnosis and with the visual query language and dig in a very manageable way and not have to say, oh, I want 30 minutes of packet data and then try and analyze it yourself from there, right? It's a huge difference in the way you access the data.
Okay, very good. Thank you. And I think we set up the audience just enough now. But before we go and see the demo, Paul, you have any comments, questions? And before we do that?
No, I'm just interested to see. I love the idea of starting from the top and drilling down. I think I've blogged on that enough and bored everybody to death. So I'm looking forward to see what's on offer.
All right.
Yeah.
Okay, Colin, Nick, take it away.
All right, let's see if we can switch over to a screen share here so you can actually see the platform. That looks like it's working to me. So for the 6.0 release, one of the things that we've talked about before and we'll continue talking about today is this idea of a workflow, right? And Paul, you just touched on it wonderfully. Thank you for the TF. The idea of this top-down workflow is really, really valuable. And I do want to iterate, and if we have time, I'll show you the other ones as well. You can get to the data from anywhere you want, whether it's top-down or bottom-up or middle-out, or all of those things are totally available. But the top-down workflow is really, really easy to use, and we're making it a lot more efficient, and we're making it easier to access for different folks across the organization, right? We really believe that this data, the platform, the level of this kind of data can be used by folks across the company, right? Whether it's in the networking team, like we mentioned, part of the security team, app owners, business development teams. There's a reason to have information about your business and around your application's effectiveness and performance for lots of folks in the organization. The problem is it's been hard to access, right? It's been a thing that you can't always get a hold of unless you know the exact flags for TCP dump and all of those sorts of things. And we're trying to help solve some of those problems, right? So with this release, with 6.0, which like I said, just came out last week, we're focused on expanding the offering technically, yes, which we'll show as well. But really a lot of it is trying to complete the conversation around an entire workflow that allows you to get to the information that you want quickly and easily.
And this is really aligned with what we've always thought, right? We always thought, why are people jumping straight to packets first when you can get so much information at this higher level and traditionally solve maybe 80% of your problems at that level?
Absolutely, really. Okay, so we're going to go through a kind of demo walkthrough here. It's going to center around VoIP for this particular use case. I want to stress that the platform does see any information being sent across the wire. It is not a VoIP-only platform or something silly like that. It could be web requests or database queries or any of that kind of stuff, but this particular scenario goes through VoIP. So what we have here is kind of a higher level, kind of a NOC style dashboard like you were talking about, very high level if you're watching for the performance of your particular application, you want to see if there's any errors cropping up, that kind of stuff. This is kind of the place you would start. Very quickly, you can see here we have 4 different remote locations. In this case, they're branch offices around the globe, that Sydney, London, Seattle, New York, up here in the left corner. And we can pretty quickly see that what we're watching for is the call quality, and that's monitored by MOS scores. It's a mean opinion score, which kind of dictates or depicts rather the quality of the individual VoIP calls that are being sent from those locations. Quickly, we can see that in Sydney, we have some degraded calls, and that's probably a thing we should look into, yeah? Big red numbers on dashboards, generally not good. If you move over to the right a little bit, we can start digging into more information about, historically over time, how has the success versus failure rate looked? What is the common trend of those things over time? We can see the average number of calls that are successful versus failed and all those sorts of things as well, and very quickly visualize the information that we're getting into.
And that trend line is user definable, right? It's something that you determine. You say, hey, this is what I think is a concern or not. So this puts tier 1 folks in control. They're able to act on this information.
Right, so this trend line here is dictating information about that average over time. What Nick's talking about is actually a feature for 6.0 that we added here that allows us to set a threshold that is user definable, so we can say, hey, on this particular set of data that's represented in this chart, you don't have to be an expert on whatever data is in this chart. I can add a line here that says, start getting concerned at 75%, call somebody at 100%, right? So it makes it very easy to consume this data. You don't have to be an expert on the exact deployment. You can start interpreting the charts right away as a perhaps level 1 engineer, et cetera, et cetera.
And it's really interesting. We've gone to this page here because this is actually another part of what's new in 6.0, which is NetFlow. We've added NetFlow to kind of round out our data sources.
Was there a question?
I was going to say one thing nice about these graphics is management can actually understand them.
Yeah, they sure can, which is a great thing, right? And not only can management understand them, but we can package these things up into like PDF reports or Excel reports, and you can ship those things off as needed. So they don't have to log into the box directly if you don't want them to.
It's actually enough that they think they understand it.
That's always been the danger of giving management too much knowledge.
Yeah. Okay, so to Nick's point, some of this data is new for 6.0, and the idea of adding both NetFlow and SNMP actually, it's actually pretty important because we're getting more of a holistic picture, right? Before we were ingesting whatever data you could feed us off the wire via a tap, not a span obviously because they're apparently evil and wrong, but taps. But whatever data we could ingest, we could see, right? Which does not include information about things like link utilization on a remote router, which is exactly what we're looking at here. And it's important to this picture. Pretty quickly, you can see here that I have multiple locations around the world, but Sydney is the actual remote office that's having a problem. We saw that there were dropped calls in Sydney. We can immediately see that there is actually a link issue in Sydney where we're slamming the router for some reason, and we want to start investigating what's actually happening in that location. We can dig down through more information about, all kinds of table stakes but important things about network performance like retransmissions and round trip time and all those sorts of things. We've been doing this for a long time. It's very valuable, but it's not anything exciting and new. It just paints the picture of what's happening in these locations, right? And then we can get into more information again for 6.0. We can pull in information from a source like SNMP that can give us another layer of data about what's happening on these remote routers. So we see a link being utilized, but the CPUs aren't getting crushed, so these boxes aren't melting. We just know that we're tapping out the resources in one location. All right, well, that doesn't tell us what's happening, just that we are correct. There is actually a broader problem than just VoIP in Sydney. So now, like any good NOC, we want to dig into that particular location. So we have our handy-dandy dashboard that shows what's happening in Sydney. And again, we're not shocked to see the routers with tons of link utilization and bits in and bits out. when this starts to get interesting and give us more information about not just that there is a problem in this location, but what's happening, is when we start digging into things like protocol data. So now we can see which particular protocols are constitute the traffic on these links. And as you can see, most of these things are so small they don't even show up on the chart because they're being dominated by port 455 traffic, which is CIFS, right? It's file share traffic. So we can continue digging into that and see not only is it that type of traffic, but we can see where it's coming from. So I can pretty quickly see our top talkers. I can see the representation of proportionately how much data is over this protocol versus others. And then I think where it starts getting interesting is we can paint this picture, again, using NetFlow information, about conversations, right? Not just, hey, you know, this 2.32 box is sending all of my data. I can see who it's talking to, and I can see over which port. So this paints the picture in one concise little list widget that has, you know, a sparkline that shows data over time, that I have one server, I have 6 clients, they're talking over CIFS, and that's the majority of my traffic. I can see all of that in one place.
And already you kind of get a story here. You kind of know what's going wrong, right?
Yeah, we saw that there were dropped calls. We see that there's a link being pegged. We see that that is likely because we're having a huge amount of CIFS traffic. But we want to dig deeper. We want to know what's actually happening here. And frankly, I'm less concerned about the CIFS itself. I know now that there's perhaps an overflow in that data center. I want to dig into the VoIP stuff and figure out what's happening with my calls. So this has all been, again, top down. This is high-level data. It's great. It's rich. But we want to see the actual transactions. And one of the things that's really, really powerful about the platform is that it allows you to get to an each individual transaction view. So now what I'm looking at is as the data has come across the wire, and we've yanked, like Nick was saying, the appropriate metadata out of each transaction, we're able to store those things in transaction records and level up whatever information you want. So this view is completely customizable. You can go through and decide you know, which fields you actually want to show here. But we have a pretty solid view of VoIP traffic. Again, this is categorized by VoIP, and we're digging into just that. It could be any kind of traffic if you wanted it to be. But here's each call. Every call broken down over time, and this is, you know, always on, always listening. So we're able to store these things historically and dig back through them in case we're going to see, you know, was there a dropped call last month, or, you know, how many calls did user Ken Pickles make, those kinds of things. We can see when it happened, who the calling party was, who they called, where they came from, just a ton of information about that particular call. But what we're concerned about, if you remember the first chart, was low MOS scores, right? That mean opinion score talks about perhaps dropped calls or at least degraded calls. So what we're looking for is a mean opinion score that is less than, let's say, 3. This is bad, right? If you have a call that is below 3, the chances of it being usable are slim to none.
And here's what's really interesting is this could have been a problem that's been happening for the last 2 hours. And if you were relying on packets at this stage, you'd be collecting, you know, gigs of traffic to try to sift through to find these 4 different transactions that were problematic, right?
If you could find it, you'd be lucky to, right? So now we have found, yep, there in fact were, it looks like 4 particular calls. These things have a MOS score that's below 3, which is abysmal. So we know that these people are struggling. They're either already, you know, complaining to somebody and creating tickets, or they're about to, and we can go in and figure out what's going on with these things. So already we've pinpointed quite a lot about this. We have really, I think, most of the data that you might want to solve the problem, but what you're able to get into more deeply here is now prove it, right? We see a lot of times organizations say, that's great, you have your tool that's showing you all kinds of information about the transactions, but if you want us to, in this case, for instance, maybe change the QoS and the routers to make VoIP more priority over CIFS or whatever solution they want, you have to prove to us what's actually happening here.
I need the packets.
And, you know, as much as I may love or hate packets directly, that's the currency it has historically been, and so folks want access to that, right?
Yeah.
And at this point, I'm sure you guys have plenty of experience with packet captures and continuous PCAP, and it's not a new art, right? It's been around for a long time. Continuous PCAP is not exciting. It's commodity. But at this point, if I said, oh, here's my timestamp, I need to go back and get packets from a few minutes before that, because I have to capture both the head and the end of the conversation, until probably, what, 5 minutes after the fact. I have to go into whatever platform I have and enter those parameters in, make a query, walk away for a few hours while it crunches through who knows how many gigs of data. it spits me out a giant, probably multi-hundred, if not multi-gig PCAP file, and then I'm going to start trying to dig through that for these specific packets that relate to this transaction.
Doesn't sound like a lot of fun.
But that's reasonable. Yeah, that's a workflow that you're familiar with. Yes.
Sorry, I was on mute. Yeah, that's certainly familiar with that. Yep.
So at this point, because we have this platform that has been storing metadata all along that we're now digging through, right? Rich data, you can go play in your own traffic however you want and add these visual queries and this kind of stuff that is working off of metadata. We already understand which flows created this traffic, right? We know that there was a flow where Tom Rowe tried to create a call, the call was established, it had a horrible MOS score. We see all that information. Also capturing packets that entire time in our new, it's the ETA appliance that Nick was talking about, that allows you to have this continuous PCAP thing, which by itself is kind of commodity, but when you tie it with something like this, it starts getting interesting because we have tied the flows together. So if I want packets for this one conversation, all I do is say, give me those packets, and it does. It knows which packets were associated with that particular transaction.
And I want to point out, that's 55 packets at 34 kilobytes.
Yeah.
That's it. That's all you need.
And it knows where the first byte was. It knows where the last byte was. It knows everything in between. You don't have to go say, give me a certain time window, go dig through gigs of data. And it doesn't take hours and hours. It takes exactly that long. And then we're not even done with it yet. We can preview. Here's each of the packets. Here's the same visual query language. I can say, add more filters. I only want certain things. I only want, whatever they are, right?
And that's the same visual query language.
Yeah, the exact same thing. And once I'm ready to actually view this stuff, now I can download it. And if I grab the PCAP itself, this is going to open in Wireshark, which is not screen shared, so bear with me 1 second here. It opens up in Wireshark, which you can't see because the screen share is just showing my one screen now. And we have actual raw packet data that you can navigate to via whatever means you're used to seeing these things. Let's get to that, and we'll share there. So this is the PCAP that I just downloaded in whatever that was, 10 seconds off my system, and you have exactly what you expect. You can then ship this off to whatever team, the network team that wants to see proof of the fact that you need to change the settings somewhere to prioritize VoIP or whatever the story is you're trying to tell. You now have access to that raw data at a level that is complete down to the last byte, and you got to it in seconds. It's pretty easy.
When we were betaing this, one of our customers said what used to take him hours that he had to go to lunch to do, now it takes him minutes, which is a fantastic way to adjust the workflow for these folks.
That's what you've done there is great, but of course the thing that was causing the underlying problem was the fact that the WAN link was, slammed, as you said, with SMB traffic. So whilst picking out these packets is obviously really useful in this way, what you really want to know is who was actually swamping the link and what were they doing at the time, which obviously would be where you would have to go and grab a slice of a trace clip of a certain width, and try and find out what's actually causing that problem at that time.
Interestingly, no, we can navigate directly into that traffic as well. So if I want to see what's happening with SIFs, for instance, I can go in and dig into, here is a list of all of my servers that are sending SIFs traffic. I can go in and start digging through, which devices are sending traffic, how much they're sending. I can dig into information about, what each of those individual systems is doing. And I can pretty rapidly start seeing, which systems are perhaps pegging that link, and I can figure out the clients and what files they're sending, and I can dig as deeply into that traffic from this same view with the same interface, and again, drill down into, if I want them for some reason, the packet, the exact same interface.
Can you time bound it as well? Can you sort of say, show me, who's sending SMB traffic for, a period of 30 seconds before and 30 seconds after the end of the call?
I sure can, yeah. So there's the idea of a time picker built into our standard UI. So right now we're looking at the last 30 minutes of data. I could go back hours, weeks, or I can actually create custom time ranges as well. So I want to see exactly, like you're saying, 5 minutes before X timestamp and a delta of that until 5 minutes after. So I can, I go find the calls that failed. And like you're saying, then adjust my time window to be, okay, from 5 minutes before until 5 minutes after, what were people doing? Yep, no problem. I can navigate.
And then obviously what I'd want to do is I'd want to go into the guy who's sending the most traffic. So, I don't don't know what you've got there. It looks like titanium extrahop.net is setting in quite a lot.
Right.
Oh no, they're ranked anyway. I'd want to go in there, and I'd want to find out something like looking at the NT create requests so that I can see which files and directories are being manipulated, and then I can perhaps tell what they're doing, because the user might not even be aware of what they're doing that's causing the issue.
Absolutely.
I'm thinking of things like, I know, like I look at problems with document management systems and things like that, and there's a lot of things that happen in the background that even the technical staff are hardly aware of. So having the ability to go and find out actually what's happening at that point in time, that's really cool. So
exactly what we're talking about, right? I want to dig in. We parse a whole lot of protocols by default. CIFS happens to be one of those things. So we understand the protocol, not just that there is traffic that is tagged on this port. That's not how we analyze protocols. We're digging into the protocol itself and looking for, distinct header information and body tags and the way that things are actually broken out in the protocol that we expect based on what that data is.
And that's also a big differentiator for us, because we're talking, we parse 50 some protocols and our competitors don't. And so, the challenges in IT like this, and like we've seen in this demo here, is that you often think it's one thing and it turns out to be something completely different. But if you're not able to get to layer 7 visibility with all these different protocols, you're going to not have a hard time solving that problem.
Yep. Yeah. So just like you were asking about, you saw that you were correct. The titanium share was seeing a lot of traffic. We can pretty quickly go through and see, all right, if that's the part that's causing a problem, how much data is being sent based on each file, based on each, open. There's a ton of information we can drill into here based on opens, closes, reads, issues, and all the way down to what I was just showing was actually this files tab here that goes through and shows each actual file or directory request that was sent. So we can definitely get to that level of data if you want it.
Sure. Yeah. Okay. Got a lot of SMB1.
We do. In this demo, we have a lot of SMB1. Absolutely.
Okay.
That's most of the canned demo. Any questions about that?
Oh, I've got a whole list.
Actually,
Denny and Denny.
Actually, I usually warn people about Paul and less about Tim because I know what Tim's going to say. No, this is great, Paul. This is great.
Okay.
This is why
Paul, we can get you a demo. Don't worry. We can get you a demo.
No. This is good. Paul, go ahead.
Some of the things that spring to mind. Real time is great. I'm just wondering the challenges of encryption. I mean, even SMB3 now has an encrypted data capability. How do you see that playing out? Is that going to reduce the functionality in your box? How are you going to cope with things like SSL and SMB3 encryption?
Well, actually, we do inline decryption as it is. So if you give us your key, we can decrypt whatever protocol is wrapped in that. So it doesn't slow us down at all. We actually do line rate decryption on the device, on the platforms themselves. Mm-hmm. So all the way up to the 40 gig line rate, we can decrypt and keep up.
And if there's a concern around compliance, typically what we found is that folks that have a compliance officer who holds the keys, they would be the only person who would have access to that. They can add those to the box as long as you're not surfacing certain data that is out of compliance. Then you're okay.
Yeah. Okay. So that actually, what you've said there, especially about decrypting on real time, the speeds and the challenges of decryption, you're going to need one big box, aren't you?
Well, so it depends on what you're looking at, right? So we have a huge different set of product offerings, all the way from virtuals up through hardware platforms, and the largest boxes currently are doing 40 gig and thousands of devices. And what we oftentimes find is that folks will have headroom left in their system anyway, so they don't want to be capped anyway. But actually, on the physical platforms themselves, we actually have not custom, but we have internal hardware that helps do the decryption as well. So it does keep up pretty well.
Okay. And retention periods on the data, on the metadata. I mean, I know on the capture units, it'll depend on the size of the capture unit, but typically what sorts of periods can you expect of retention on the main system?
So it's all dependent on the actual line rate you're feeding it, right? If you have a box that is designed to handle up to 40 gig and you're feeding it actual 40 gig, it'll be less than if you have that same box and you're feeding it 12 gig, right? But generally speaking, when we size the platforms, we try and make it so that if you are feeding it at its maximum rate that it's designed to handle or close to it, you get between, like, I think it's about 3 months-ish of look back usually.
Oh wow! Yeah, okay. I was thinking days. Okay, I'm used to like large volume packet capture, and obviously we don't you can manage to get a few days. You're lucky.
No. On some of our platforms, we've seen people have more than a year of look back because they weren't fully utilizing the throughput, right?
The other thing is we don't believe in owning your data or our customers' data. So we actually have an open data stream, which allows us to push all that data out. We can feed, Kafka, Mongo, you name it. So it's one of those things where if somebody wants to keep that data for 7 years, God forbid, they can push that out and keep it.
And that's a very good point. You can push it out to any platform you want, or inherently, if you set up an NFS mount suddenly, you can expand the storage on our platform directly as long as you want. So technically, there's almost infinite look back if you want to add storage to support it, right?
Could you parse this out so you could do CALIA type warrant fold out? So if someone gave you a warrant, they would want you to parse out just whatever was on the warrant.
Sure.
Sounds like you could do that and actually feed the JTAG engine,
yep,
and then be encrypted and sent back to the main agency. That sounds. It might be an application to look at.
I've not done anything personally with warrants, but we've certainly talked to people in the legal field that get excited about the idea of they want to do forensics not from an IT perspective, from a legal perspective, right? What was this user's behavior? We believe that somebody was leaking information that they shouldn't have. Can you go find what that person was doing? All those sorts of things, right? We can do all of that sort of research and forensics based on whatever criteria the user might have.
Yeah, I mean, that's e-discovery type environment or e-forensics type environment. I was talking more about the legal application, and it could occur in a business environment. It has many, many times where you get issued a warrant and say, we think this is going on, and then you have to filter on you that IP address or specific elements laid out in that warrant. And with your filtering, it looks like it can be done pretty easily and then just parse right back out to the JTAG compressor.
Yeah, wouldn't be hard at all.
So, sorry, go ahead, Paul. I'm sorry.
No, I've taken a lot of time, and I know Denny's going to want to wrap up soon, but I was going to just ask one more question. In terms of the quas aspects, does your tool take into account the quas model that's in use, and so that you can see how effective that is within the flows across the WAN, or are you just showing what's going across the WAN without much note of the tagging and the?
So it really depends on configuration, right? That is absolutely user configurable. If what you wanted to do was build your dashboarding, or we haven't even gotten into the concept of triggers, and it's a whole extensible platform that you can do customizations on and build your own functionality. Anyway, longer conversation. But if you wanted to go and detail information about your actual quas model and put that into the dashboards and say, we should be seeing, in this use case, for example, we should never see VoIP degraded below CIFS and whatever those things are, you could build the charting to display that and then build alerts and thresholds if there were an issue, but there is no automatic consumption of that.
And there's also the ability to work with management platforms and push that out. So we can fire an alert off to your management platform, and you maybe have a run book that's set up for it that automatically self-heals.
Okay. Last question, very last question. Are you able to interface for packet data? Are you able to interface with InfiniStream, Gigastore, NetSharks? There's an awful lot of this kit out there right now.
Are you saying going and polling what they have, or sending it out, or what are you looking for?
No, I'm thinking in terms of the way that you were going from your metadata and then drilling down into the packet data. Are you able to? Because a lot of these devices have got, blimey, the names, the API.
REST-based API.
Sorry, I forgot. REST-based APIs. So are you able to interface with those?
So that's, again, a long conversation. We have, first of all, our platform itself has a fully functional REST-based API. So any configuration or data you might want to take in or out of it, you can do automatically as well. It's very scriptable, et cetera, et cetera. Also, as Nick just mentioned, based on different alert criteria or events that happen, we can actually execute scripts that would go out and make REST calls to other systems, whether that is to go change a load balancer's configuration when you see too much traffic is going through to a certain node, or we've had folks go out and poke VM systems to set up a new VM. There is no inherent integration with those platforms that you're speaking of. We don't have any built-in tools that can do that. But we have the ability, if they have an API and there's a call that you want to make, we can automate that. Right?
Well, I'm going to challenge you on this one because we actually do have one integration because we just launched something at VMworld, which allows you to, one, push out an appliance in a virtual space, to collect all the virtual switches, right? And then we have the ability to feed into VRO, VR ops. We can actually feed it wire data, so you can mash wire data up alongside machine data.
Yeah, we've done some integrations with plenty of third parties. Yeah. None of the ones that I think Paul mentioned specifically, but those things are absolutely possible if you have the API schema and you want to write the calls, and you can do those sorts of things.
Okay, thank you.
Absolutely.
Hey, can I have one question, please?
Go
One
ahead,
of the
Tim.
things I think you guys don't talk much about is your ransomware capability, and I would really like to come back and talk about that another time because it's becoming, we're 30-something% more attacks this year, and the majority of those that have caused massive damage, and we're going to see more as IoT begins to expand. And I'd like to talk about that if it's something you guys would like to talk about.
Yeah, we'd love to.
Down the road, not tonight.
Well, yeah, we have that whenever you'd like it. We have quite a solid ransomware story, actually. It's one of those things that the platform, we don't oftentimes talk about it as directly a security platform, but as you're seeing, when you have all of the data, there's tons of uses for it, and security absolutely is one of them.
Absolutely.
As we see everything transacting over the wire, we can very quickly identify some of the algorithms that indicate that ransomware is occurring over your file shares and whatnot, and we can surface that up, create alerts. We can show you not only if it has or hasn't happened, which systems were infected. We can show you who client 0 is. We can show you which files on which file servers were touched. You can go clean up specifically those things. There's a whole story around it we'd love to show you.
And it's all based on the behavior, so there's no need to have a known ransomware distro. It's anything, we can see it.
Right.
Well, that's important. I think we ought to come back and have a security discussion because, data leaks, ransomware, stupid users, just a plethora of things we could talk about. I'd love to do that later.
Sure thing.
Danny?
Yeah, thank you, Tim. Thank you, Paul. Hey, Colin and Nick, before we close the show, I would like to give you a chance to kind of give a shout out to some of our audience who might not be familiar with ExtraHop. And after what we talk about today, what would be that one or two things that you should that would really resonate with them that they should take a look?
I mean, from our story perspective, I think the first thing is they have to rethink the network, right? I mean, the IT ops guys, I talked to a lot of IT guys, and the minute that you talk about protocols or packets, they're like, oh, that's the network guy's domain. But the reality is that the network is probably the richest data source you're going to have in your environment because it's going to see everything, right? And it's what's actually happening. So first is rethinking it, making that be a part of what you're doing. The second thing is really embracing kind of a newer way of doing things, new workflows, save time. You kind of have to rethink how you're doing it and not starting with the packets, but starting at that higher level and then drilling down as needed.
Mm-hmm.
Yeah. What's the application doing? What's the user experience look like? We're starting to look at things that are, like Nick is saying, higher level indicators rather than just exactly what's happening on the network itself. You're talking about the network as an indicator for how application or deployment or user experience is performing, right?
Mm-hmm. Thank you, Colin. Thank you, Nick, and really nice to have you on the show. Really enjoyed this one. And with that, I'm going to close. Paul, any last word? Before we do that?
No, I do like the philosophy of using network data and wire data as a rich source of performance and stability information, and that's what we've been trying to do for years. I agree with the guys. It so often seems to be just assumed that it's the domain of the network people, where you can show a DBA, the SQL query, from a network stream. And it blows their minds. They can't believe that you can get that sort of information. So, yeah, it all sounds good to me.
Thank you, Paul. And Tim, any public announcement, anything that we should do before we close the show?
No, just be safe. And I want to shout out to Jesse and Raj. They've done a hell of a great job, and I really want to get them on here so we can talk about what stimulated them to want to develop ExtraHop. We've talked about it individually, but I think it's important. You got two guys who are incredibly brilliant guys who started ExtraHop. And I'd like to talk about that. I want to talk about your security applications. That's my world. And so I think you guys have done a hell of a job. Thank you very much for coming on. And look forward to seeing more. And by the way, you guys can always put articles up on Love My Tool about stuff that's cool.
Cool. Well, thanks for having us.
Yeah, thanks for having us.
Yeah, thank you, Colin. Thank you, Nick. And with that, I'm going to close the show. See you next week. And I'm not sure who we're going to have on, but it would be great. Thank you. Bye-bye.
Thanks.
Hang on.